In this video, I'd like to chat with you about a few of the ingredients and commands that you and I are going to use to implement DHCP snooping, and also reinforce where in our enterprise we're going to implement this feature. So let's consider where a rogue or malicious DHCP server might be injected, and it's very likely going to be injected where users can connect to the network, and that's the access layer. So if we have access layer switches with wiring that goes over to the offices and cubes, it's really here at the access layer and the access layer switches where we want to implement the feature of DHCP snooping. So let's imagine that for this network up here, let's say this is VLAN 30 that's being supported up here, and then these are trunks going down to the core and distribution layer. And let's imagine our DHCP server is right here, our legitimate one. So to implement DHCP snooping on this access layer switch, here's the command we'd use. We'd use the command IP, DHCP, put my little spaces in there, snooping, enter, boom. Now that enables DHCP snooping the feature on the switch, but it doesn't apply the feature to this VLAN. So we need to add one more command, that is IP, space, DHCP, space, snooping, space, VLAN, space, and then if it's VLAN 30, we'd put a 30 right there. So now with this 1-2 punch, the feature is enabled and it's applied to VLAN 30. So with this in place, let's consider this machine right here. We'll call it PC 1, 2, 3, 4, 5. PC 5. It boots up. It's a DHCP client. It does a DHCP discover message. So in the discover message, it's going to send out a frame, a broadcast frame. And for the source layer 2 address, it's going to use its MAC address. And then inside the DHCP message, the discover message, it's going to include its layer 2 address. If those two MAC addresses, the one that's in the layer 2 header and the one that's in the DHCP discover message itself, if those are not the same, this port right here says, I'm not letting that go in. It's not congruent. Something funny is going on. And that's because all the ports in this VLAN, VLAN 30 by default, are considered untrusted. And so there's some extra inspections that are going to go on as a result of that. Also, if Bob or somebody else plugs into an access port here and they have a DHCP server, meaning they have a device that's trying to do DHCP offer messages or acknowledgement messages, if the switch with DHCP snooping sees any of those server type DHCP messages trying to enter the network on a non-trusted or untrusted DHCP snooping port, it's going to drop those. And that way we're protecting our network from having unauthorized DHCP servers added or connected to our network. So if this client does a discover message and that discover is broadcast and it's forwarded down the trunk and this DHCP server sees it, my question is, what's a really good DHCP server going to do if it gets a discover message? Well, you might be saying, well, Keith, it's going to respond with an offer. Exactly. And that's where the problem comes in if we have DHCP snooping enabled for the entire VLAN. Check this out. When the server responds with the offer saying, hey, I've got a beautiful IP address, you're going to love it, and it tries to send it into the switch, it goes in here to core 2 because core 2 does not have DHCP snooping enabled. That gets forwarded up the trunk and up to the access layer switch. But right here on this trunk port, guess what? DHCP snooping is enabled for VLAN 30. So that's tagged VLAN 30. It's a DHCP offer coming in, and the access switch says untrusted port and kills it, which is not the intent. So what we'd also want to do is we'd also want to specify from the access layer switch's perspective which ports are to be trusted, meaning which ports lead to legitimate DHCP servers. So on the access layer switch, if this is port 0/1 that goes down to core 1 and 0/2 that goes down to core 2, we'd want to configure both of those trunk ports as being trusted, IP DHCP snooping trusted ports. And the syntax to do that would be to go into interface configuration mode for these two trunk interfaces on the access layer switch, and we'd use the command IP DHCP snooping, I'll put a snoop for short, space, trust. And if we did that for each of these two trunk ports, that would make them trusted ports. And as a result, when the DHCP server sends its offer and its acknowledgments and messages from the server back up into that access layer switch, the access layer switch will allow it because it's coming in on a trusted port. So in this example, all of the access ports would be untrusted from a DHCP snooping perspective, and the trunk ports would both be configured as trusted ports. And there's one more element that often causes DHCP snooping to be so good at what it doesn't allow any DHCP services to work. And that is option 82. In many networks, there's DHCP relay agents. that listen for DHCP discovers on a given broadcast network, and then they unicast that, or they route it over to the DHCP server. Well, option 82 includes information about that DHCP relay agent. If we're using DHCP snooping, it can add that option 82 information as part of the DHCP request. We don't need that added information. In fact, if we add that information, it might cause DHCP services not to function correctly. So this command right here, no IP DHCP snooping information option, says don't, please don't include the option 82 information to the DHCP messages. And sometimes if that information is left on and DHCP snooping injects it, it causes DHCP services to fail. So please be aware of that command as well. In our next video, join me as we take a look at building a small network where we can implement DHCP snooping and verify its results. So I'll see you there in just a few moments. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.